engineer, just like Carsten and most of the other guys in my team. And together with Carsten in, was it 80 and in 2002, I think, we did S390, the first S390 port to Red Hat Linux at that time. Not Enterprise Linux and not Fedora, it was Red Hat Linux at that point. So I've been involved in secondary architectures for a long time. So, and we've been doing a lot of stuff in the past couple of years on secondary arches, lots of stuff happening there. So I'm just going to briefly go a little bit over that and what we do and everything. So first up, as I said, brief history of what we've been doing. Then what we actually currently do in Fedora. Some of the fun facts, some of the things that we do, and what we actually really like new things that we do there as well, which is really cool. How you get in contact with us, because I mean, as Dennis yesterday mentioned in his nice talk, we always look for people helping us, obviously, because it's, I think, a great and fun place to be and to work with, and we enjoy people helping us and working with us. So. And I put summary at the end so that you know that the 3 key points that we should take away. So brief history. It all started with this. So there was one cell organisms at some point in the past that at some point over the history of millions and billions of years then brought up humans that brought up this. So we're kind of there now. A little bit later probably because that's a Z Enterprise, a System Z. Sorry I didn't find any power pictures quickly enough, but it's IBM, it's green, it's fine. So that's where we are these days. To be a bit more serious, computers, if you look at the past like 50, 60 years, they have evolved drastically from all kinds of varieties, all kinds of machines, bit sizes, CPUs, whatever, you name it, architectures, buses, and so forth. A lot of them have gone extinct over the years. I still find it sad, for example, for Alpha that it's gone away. I love that architecture. I'm not all that worried about IA64 now. But new ones come out every day now, still today. Look at AR64 just recently, for example. But there's also, even in embedded spaces and other things, there was a new architecture just, I think, a year or 2 ago that we did actually a project on internally at Red Hat to make RHEL run on, which is, I think, was called something like Tiny or PRAL or something like that. Completely odd architecture too. So there's lots of machines coming out. The kernel itself already actually supports more than 30 or about 30 different, really completely different architectures, which is an awful lot if you think about it. And there's all kinds of stuff in there, which is really mind-blowing if you think about it, on what kind of platforms actually the Linux kernel is running on. And there's actually, as I can see in this room here, obviously quite a few people who do like to work and work on non-mainstream architectures like non-Intel systems, because they're fun and they actually prove to be challenging at times, which is something that engineers typically really like and love. And last but not least, and this is really something that we should also always keep in mind, we are working every day, or a lot of us work on Intel systems. They work on some cases really well. They're really good for some things, but other architectures, be it Power, be it AR64, be it System Z, have strong points in very specific areas too that you just can't get to with an Intel platform, period. And that's something to also keep in mind. So, like a good engineer, you should always think about the right tool for the job, right? And same with architectures. There are sometimes architectures that are just much better for the job than Intel or others. Now, what do we actually do in Fedora? So we're a small team from Red Hat internally, and a small community around various architectures and partners. We have a couple of guys from IBM, for example, here today with Jeff Steele and Mike Wolf. They work with us on the Fedora side on getting Power and other architectures, AR64. John, for example, John Masters is doing a lot, like publicity work through there and then engineering stuff. And System Z, we work with the folks in Germany from Chennai, for example, a lot too. And obviously also with people from the community a lot. I mean, ARM, for example, ARM32 went with the help of a lot of folks there from a secondary architecture to a primary too. I mean, there were a lot of people involved. But we do like our place in the secondary architecture because we have some distinct more freedoms, basically, than we do in primary. Primary is very specific and strict. Sometimes we're just a little bit more flexible in secondary, which is good. Nonetheless, we still do and try to follow the release plan and process from primary as closely as possible. Simply for the fact we have a small team and we just can't run around, do wild cowboy stuff. And if we do that, then we're so deviating from what actually Fedora primary is doing that what we would end up having is not something that you would normally consider a normal Fedora, but something cobbled together from Fedora pieces. And that's just not good. Because at the end of the day, at some point, we want to use those bits also to go to our RHEL products. So if those deviate too much, that's just not going to work. So our main focus these days, and that's where AR64 is coming into, sorry about this, is Power and System Z and AR64 in the secondary architectures. We used to have for a while still other things like Spark for a while, but I think
a very brief while.
Yeah, but I think we gave most of those were given up because.
And there's sort of growing interest in MIPS, and one of the MIPS companies is trying to hire a Fedora person basically to bring up.
Yeah.
So I mean, there's sort of architectures fade in and fade out.
It's the evolve that I had at the start. And you can really see that so nicely in Fedora, how it evolved over time, where we used to have alpha in there as well for like 10 years ago, basically, and that just kind of nuked as well. So that's kind of sad, but yeah. And obviously, I mean, it always sounds so easy, right, to do a secondary architecture. What you just need to do an RPM, build, dash, rebuild, source RPM, and you're done, right? Far from that. I mean, we would love that to be the case, but there's lots of work revolves around really fixing Arch-specific issues, or issues that actually appear on that architecture, a different architecture, that is actually a general bug. I get to some of those examples later on that we actually discovered in secondary architectures that were affecting primary too, and that kind of caused, for example, hidden stack corruptions and things like that. So we do actually, the work we do is also really beneficial to the primary stuff. And especially due to the size of the team, because we're not like 100 people or 1,000 people, we need to be really efficient about what we do. I mean, we have pretty automated processes where we can streamline the things that we do and have the processes that we do really work with multiple people and be really spread out and possibly to spread out those things. So we try to invent and do new things there, improve some of the scripts that we have, like Shadow, a couple of things.
Longer term, I'm working to try and make secondary arches be mostly transparent to, you know, to be the same in transparency. Things just happen, composers just happen.
Yeah.
It doesn't look any different. It just happens to be built in a different koji.
Mm-hmm.
You know, so that have it more integrated than, you know, 3 or 4 years ago. They were completely separate. All the secondary arch releases happened, you know, 3 or 4 months after the primary arch releases. It was always catch up, and you know, and now we're releasing secondary arches the same day as primary, and you know,
that's a huge difference from before. Absolutely. So some of the things really as examples what we did is, I mean, since Fedora 16 at least, actually for S390 I think a little bit earlier too, we did really fairly precise releases on either the same day or the same week-ish kind of for PPC64 and S390 since Fedora 16. Just recently, and that's still in progress, we're doing the PPC64 little endian bootstrap in Fedora, which is basically, it's the same CPU. I'm saying that right? But
yep.
It's just basically like on MIPS where you can flip, like if it's little or big endian. You can say we're doing that in little endian now with a redefined ABI and everything cleaned up. Also with the help actually again from the community and us, where we had a long conversation with IBM, like what would you see as problems in the current BE ABI, what do you think we should change and fix, and we gave them feedback, got responses, and that was really good, really, really efficient and good stuff that we did there, I think. The grab2 changes that we did, lots of stuff there for PPC64 and LE as well. LE is still kind of pending some of the final patches, but that's coming.
Are we completely off of Yaboot now, Phil?
Yes.
Or is there?
Yes, absolutely.
We've totally removed 32-bit
Yes.
PPC support, which means
Yep.
there is no way we can bring back Yaboot.
Excellent.
Yeah, it's dead.
It is gone.
Yeah.
Been taken
I've always
to the
said
back
being-
and shot.
Yeah, right. We can shoot the maintainer.
Yeah.
Maintaining something because you're the only one using it is not a good thing.
Tony can do now something different.
Cool.
Another really big thing that we actually did, or actually IBM did a lot of that, to be perfectly frank and honest here. Their tools guys really brought in the LLVM and LLVM pipe changes for PPC64 and S390. The LE stuff landed in 3.5, and the last I heard from Ajax, we're actually going to pull this in for F21. So we're going to do the rebase, and he was already planning on that. So we should also have a full LLVM and LLVM pipe stuff for F21 for PPC64. Because that's going to be, F21 will be the first release for LE.
Do you want us to ask questions now or save our questions for later?
Whenever.
Okay.
I'm free.
Keep going.
Okay.
Oh man, okay, I got one. What about Go?
Go. Yeah, so what about Go?
I think he's good.
Yeah. Yeah, what about Go?
Well, I'd love to try and get by with GCC Go,
Yeah.
but my fear is that the community is completely behind Golang native,
Yeah.
and that we'll perpetually be making tools work.
Okay.
So I'm actually looking for input from the broader community to know whether it's insane to try and stay on GCC Go, or whether we should just bite the bullet and do a Golang.
Ultimately, having dealt with Go on ARM64,
Yep.
and I still haven't found a whiskey shop that will sell me enough whiskey in one go to continue on doing that. The major issue is all the interesting things that are currently using Golang, like Docker and GearD and all that stuff.
And is what I worry about, yeah.
Uses a lot more of the functionality of Go than is currently available in GCC Go. And so, but Golang itself in terms of packaging is just a nightmare hellhole. Like they have no concept of like distro packaging and everything else like that, and you sit there and look at the packages and you just literally reaching for a litre of whiskey.
So which hell would you like?
I mean, so ultimately I would prefer if there was enough Go support in GCC Go to be able to use it for Docker and GearD and everything else, because you would not have to deal with API and ABI random breakages all over the place without any due consideration, because essentially it makes assumptions that it's pulling the latest everything from Git all the bloody time.
I think the tools team would also like that as well.
Yes.
So I'm on the platform tools team, so
Yeah.
we would like GCC Go to get used. The question is, what's missing and what needs to be implemented,
Right.
because if it's a small amount of stuff, then that's not actually all that much work.
Yeah, I mean, from my perspective, I don't know enough about the deep levels of Go to actually
We know
answer
enough, but our
that.
question is, what are the use cases that need us to add stuff to Go?
Well,
I think you start with Docker and you go from
yeah,
there, right?
Docker and Git and any of that. And,
Right.
I mean, like, so, for example, the audit package has recently added Go language bindings, and that was basically my exact words.
Kernel will be next.
Kernel's got Perl in there, so you know.
And Java, and
I'm just waiting for V8 support in there.
So then basically we need to work with you to find out what is missing.
Yeah, and so like, to get audit support building again, I've basically just disabled the Go bindings for all the secondary arches so that it will build. And I mean, the Golang support even in v7 is there and it works most of the time, but we've got a whole bunch of random crashes that just randomly blow stuff up, and I just sit there and shove it under the carpet, shove it under the carpet. So I mean, so I need to go back and look at audit to see if we can build that with GCC Go, and then build it like that across the board, because you know, there's things like that where GCC Go makes a hell of a lot more sense to me in terms of supportability across everything. But I don't know what the delta is, and I don't know how quickly Golang is evolving and how quickly the likes of Docker and Geard and that are picking up on those newer features, or whether they've just got a superset that we can implement and it's then fairly static.
So that's something that we can answer by looking at that.
Yeah.
unfortunately, I've been told by Ian Lance Taylor through the grapevine, who is the Go maintainer, that he has no plans to do power, despite his power heritage and our deep relationship with Google
that's
on
fine.
power.
That's why, you know, that's entirely the problem with volunteer-based secondary arch support, is that you do have to have someone to do the arch support. And he is absolutely in his full right to say, I'm only supporting this.
All I'm saying is, if I get it done like I did LLVM and hand it to Ian, I still worry he's going to say, I'm not going to stick it in. And I've heard it's a bloody mess to develop in anyway. So
have to keep maintaining a patch set on top of it.
So we need to pick one way or the other. Sounds like you're the key, Peter, at this point, as far as identifying things and then working with the tool team.
I'd rather that, we'd rather it go into, from a tools team perspective, we'd rather it go into GCC Go, especially if it's a minimal number of things. I think Go language is, you know, it evolves quickly, but I think the features that people are probably using
are fairly static.
Exactly.
And I suspect what's happened with the likes of Docker and that, now it's sort of more mature, the features that it's actually using now probably haven't changed that much.
So we should use Fedora as an integration point, like we did with LLVM, to go chase each of the GCC Go deficiencies,
so I had
build the pieces, and work on it there.
I had a very brief discussion with one of the community guys who said to me on Monday, like, what stuff, like, we have an amount of resources, what stuff is missing basically in Fedora? And I was like, Golang's one, and there was 2 or 3 others, and he's like, well, you know, but I suspect when he goes and starts to investigate, will have the same reservations as you. And I suspect ARM64 probably has a slightly better chance of getting it upstream, but that's simply because Android and Chromebooks will be very soon running ARM64. So there is a certain level of interest there.
So one of my philosophies in life is it's better to be consistent than it is to be right. So we should probably also double check with the ARM64 team and make sure we go the same route that they go. Because I don't want to be stuck as GCC Go on power, and 390 will probably follow us.
Ultimately, as Carlos says, I think generally in like the Fedora side of things, like, I mean, new versions of Go have broken stuff on x86 on Fedora, and, you know, they've had to, I think, go and patch Geard and everything else. So I think for the sanity of the distribution as a whole, even on x86, for that stuff that we want to be stable, because everyone wants Docker and everyone wants all the stuff surrounding that, I think if we can go the GCC route, all the better.
So
is it reasonable to take some of these key apps that use Go and instead of necessarily bridging every gap between GCC Go and Golang, to
implement the required functionality.
Port some apps to GCC Go.
Yeah.
Yeah, and I think that's probably what Carlos was indicating, as in,
Yeah.
let's find out what's missing, implement it so that we can build them against GCC Go.
Yeah,
You
I
can
think-
make Docker work on Power and AR64. That would be a huge.
Yes.
But I
Well,
don't,
and
I don't,
AR64 as well.
yeah, I mean, but again, I'll say conservatively, I don't know how much more is required beyond GCC.
My
beyond
team's been looking at that already.
Okay,
So,
I don't know your name.
I'm Jeff Shield.
Jeff Shield.
I'll chat with you.
I'll come and speak to you shortly.
So I think the tools team feels responsible for doing a couple of things, and one of them includes cross-platform language supports that come out of GCC, particularly for secondary artists that we end up caring about later on.
Yeah.
So GCC Go is a great example of this. The other good example is we actually have a GCC jitter, and we've looked at replacing Octave's use of LLVM, and the other one is Mesa's use of LLVM as well, with a GCC jitting implementation to provide some kind of cross-architecture consistency, because GCC's backends target so many other architectures than LLVM does at the moment.
Yeah.
It would enable more consistency across all the Fedora builds if we could sub in, and I think Ajax would be happy that LLVM.
Oh yeah.
LLVM could be a choice you could swap out. Again, I'm not saying you remove it. I'm saying you provide your downstream users with as much choice as possible, and providing them with a jitting implementation based on GCC to swap and make that choice.
Yeah, like HFS Plus used LLVM, and it caused us major problems in ARM-v7 and again in AR64.
Yeah.
And playing is horribly broken on 32-bit ARM.
Yeah, and so someone went, why don't we just look and see what it's actually using? And they went, there's like a dozen functions, and the patch is like maybe 100 lines of code to actually remove the requirement on LLVM. And so someone just wrote it, and suddenly the problem's gone away on all the secondary arches, and it just works. And you just go,
that was easy.
And the code was actually cleaner with the LLVM support removed.
What needs to happen is if you run into those problems, like absolutely reach out to the tools team. We are there to provide answers for how you replace core tools components with other core tool components and answer those questions. So,
cool. Great discussion.
I don't want to. Yeah.
No, that's good. I mean, that's why we're here. And I love this about talks. I mean, I like doing talks that are active with the audience, because that's the whole idea. If I drone around here and you're all sleeping later on, I didn't do my job. So it's good that we have this discussion.
yeah, and I mean, ultimately, in the case of like the Golang discussion, that I'm quite happy to be a conduit between my IBM and you guys and you know, other architectures.
One question I have regarding actually the Golang stuff. What's our current, how do I phrase that, connection with Google? Like, how do we work with Google on Golang, GCC Go, like, interaction? Is there any?
For Power, I can help.
Okay. Okay.
Yeah.
Good. All right. And I mean, then maybe you and Colors need to talk, because that would be, if we can leverage that for not only Power, I mean, Power Up is...
I said I can help with the discussion. I didn't say we could leverage anything.
I said we leverage.
I mean, like my understanding in terms of like the Golang support in Fedora, there is no discussion with Google at all.
Yeah, I was about to say the same thing.
I mean, Denise may be able to put something in from a like corporate perspective, but like I think from the community's perspective, we basically pull whatever they dump over the fence and build it, and it regularly like breaks a whole bunch of the internal stuff.
The biggest problems that I have with Google is that their fundamental use cases do not match any use cases anyone else in the world has.
Yeah.
And so we see this upstream a lot, that Google comes and says, I've got problem X, and I'm like, you are the one person in the world that has problem X.
Yeah.
No one else really cares about problem X. And so that there's
Except
a bit of
for maybe like Facebook and Twitter and all
there's
those
a bit of a
big scale
dissociation between what they want and what anyone else wants.
Yeah.
So I don't use them as a good use case for Fedora. I would not use them as a good use case.
Yeah, and I mean, you look at all the products that we're consuming into Fedora or into the Fedora surrounding community, Golang, Chromium, like
Yeah.
they're all sort of almost crack-filled. Like the latest builds of Chromium actually ship a forked copy of LLVM within the source tree.
No, Chrome and Chromium are insane.
Yeah,
They're just
and like,
nuts.
yeah. So, you know, they just are increasingly making it harder and harder and harder for anyone to consume any of their supposedly open source products.
Yeah. They are open source, you know? Like, they, capital letters.
Yeah. Yeah, they do not equal us.
Yeah. All right, let's get a little bit further. There's not many more slides, so we can keep on the discussion later on. So another thing that we did, and that actually grew kind of on my plate as well, was the PPC64 P7 subarch that we did in Fedora 18, I think. Kind of a neat trick to actually have a couple of packages optimized for Power 7 and up in Fedora without having a real new architecture. And it was actually surprisingly easy to do in RPM and Yum. That was not a whole lot of work, and it works just perfectly well. It actually added a couple of really interesting and missing pieces in Yum too, for the AT platform support, for example, that was needed for P7 for detection for CPUs. So there are, again, benefits that Yum, for example, got for general purpose stuff that you could use then from now on, and that's just really cool stuff. KVM on PowerPC 64 and S390X. So the later one is, it's in Fedora. We've kind of tried it. It kind of works.
It works.
Yeah, but IBM says, oh, there are bits of S390. Oh, that's interesting for KVM. Wow, where did they come from? Well, we're not going down that road, but it's fine. For PPC64 though, Jeff's team has done a bull's job here on getting this stuff done. And you know, are the Power 8s shipping yet?
Yeah.
Okay, so the Power 8s are shipping, and they have a option of getting a Power KVM as opposed to a Power VM underneath it. So you actually run kind of a KVM hypervisor at this basic platform, which is awesome. I mean, this is exactly the cool stuff that we're seeing here. Innovation, really being on the front line here, and kind of having a firmware on KVM basis, really. So that's really cool stuff. And last but not least, I mentioned that in the slide before, we do a lot of cross-arch bug fixes too. Just recently, we had, was it a GCC bug, I think, that we discovered on S390?
Yeah, at least 2 GCC bugs
Yeah.
that were discovered on 32-bit S390, and it was, the real cause was in some generic JCC code optimization, not really tied to S390 itself, just the general code.
Yeah.
Is this your definitive list?
No, no.
You have a second page?
It's an etsy.
Oh, okay. I was going to say, because, you know, we did also an awful lot of Anaconda work, especially in the area of multipath and some of those others where we...
Yeah. I just wanted to list a couple of those. I mean, the basic foundation with GCC and glibc, where the impact is so huge on everyone, where we find stuff. At glibc, I have a very old example where I think 7 years ago, I fixed a bug in the Sun RPC code that was actually only triggered on big endian machines, and it triggered immediately if you tried something, but on a Intel box or a little endian box, you would have to really try hard to actually trigger that problem, because you'd have to go to, I think, 32 or 64 even file descriptors at that point until the bit mask at that point would break. And on big endian, damn, first file descriptor you opened just crashed. Basically got the process to 100%. So, and the list goes on and on. I mean, libFFI was another one where we discovered things that were just, from a design perspective, even broken. And I think we're still in discussion with upstream and the maintainers there how to actually appropriately, correctly fix this. But it's a long discussion, and this is stuff that really affects everyone. With libFFI, we had one bug that we fixed that was actually causing a hidden stack corruption on Intel. That people did not see, because, I mean, this corruption was so small that you wouldn't trigger the canary on the stack. So it was just a very tiny, small flip there. And that would have caused, in some cases on Intel, some segmentation faults in your GNOME. And you wouldn't know for the love of God where it came from. On Power, we immediately discovered it just by booting up the machine. We just crashed, I think, in debugs immediately, and we figured, oh, there's something wrong. And investigated, fixed it, and so that bug is then also done for primary.
How do you manage the life cycle for some of these systems? So I know you just said that for Yahoo being gone, that means you won't be able to boot 32-bit power box, so like PPC 604E, like an ancient box. It's kind of another question at this point. I assume we're still supporting the 32-bit runtime and still run 32-bit miners?
It's gone completely.
As of
Okay,
21.
so
As of Fedora 21, it's gone completely.
how do you, so again, my question about life cycle pertains to the fact that are those 32-bit runtimes are things that would eventually go into a stabilized version of Fedora, which would be RHEL or any other distributions that are based on it. That being missing, is that a problem? How are we communicating what's happening to the runtimes? For example, PPC 64 P7 is a good example because the Power 7 runtime is effectively going to become the de facto runtime for PPC 64. Right. Power 6 and Power 5 are going away. Yep. What do we tell our Fedora users about Power 5 and Power 6 and that we're basically migrating to Power 7?
Simple, buy new hardware.
So if that's the answer to the life cycle,
you're doing the same thing with RHEL. Yeah. RHEL is moving forward as well. So
well, but you have RHEL 4, 5, 6 the supporting longer.
Sure. Right. Exactly.
Yeah. Right. So for Fedora is just you move forward, and the reason I ask the question is because for glibc and the Core Tools platform team, it matters what. The number of runtimes we build makes testing harder and it makes it more complicated for us to support those core runtimes working properly. So the more we have, and I've seen this in some cases where you continue to carry baggage of Power 5, Power 6, Power 7, Power 8.
We want to deprecate those and get off of them, just like we dropped the 32-bit stuff. And so the answer to how did we drop 32 was we started a lengthy discussion about, guys, this is going, who wants it, stand up, volunteer to fix things, we have some defects, go to work. One guy says, yeah, I'll help, never shows up.
Yeah.
So that was...
I don't think you're obliged to be more nurturing than the hardware.
Part of how we managed it with like Power 7 is by introducing the sub-architecture in RPM and Yum so that we can provide the optimized Power 7 version so we can test that. But it also kind of gives a heads up that, hey, we're going this route, and at some point we will drop off.
Right.
And in the case of like...
But remember that providing a Power 7 subarch has interesting implications for what runtimes have to be provided from Fedora. For example, when you run this Power 7 subarch, what you're actually relying upon is the fact that we are shipping a Power 7 runtime in glibc, and that when the kernel's at hardware caps selects Power 7, that there is a Power 7 directory with everything you need built in there.
Right.
I mean, ultimately, like with the dropping of Power PPC 32, there was discussions ongoing over about 4.
Yeah.
I think like the first discussion started around F16 about dropping it, and when it came up in discussion for dropping it for F21, there was a whole bunch of people going, no, you can't do that, we'll support it. And so it was going to move to what was considered as tertiary architecture. But they, for that, have to provide Koji and build systems and everything else. And they're like, we're going to do it, we're getting it all together. And like 4 months late, like it was always going to be, it'll be next week, and like 4 months later, it never happens.
It's a ridiculous amount of work. I understand how much work it is.
We know this.
Yeah, I know.
So we had the same thing with when we dropped the software floating point support and went to hardware floating point only. We said, hey, this is what we're going to do, and I mean, when we said all right, we've decided that Fedora 18 was the last release that we did software floating point, and we announced it as people like, I've got this hardware and you can't do that. I'm like, well, you can,
step up and
do it yourself. No one ever did.
I actually got hate mail over it. That was even before I was. I don't think I was a Red Hatter at that point in time, and I got hate mail from the decision to drop ARM v5. But ultimately, by that point in time, ARM themselves had said anything prior to ARM v7 is end of life, and ARM themselves had no, and all the hardware that was still available was basically old inventory, and
Yeah. But the rest are ARM's and
There is no
but I mean,
ARM v7. It's a mantra.
ARM v6 had already been end of life by ARM itself before the Raspberry Pi even began to ship in quantity.
Yeah.
And that's really, I mean, the point where this boils down to, this is a community effort we're doing here in Fedora.
Sure. I was just asking, what does the life cycle look like for the secondary arches?
Yeah.
Because at some point you have to pull the trigger. So it seems like you were just having a community discussion, and at some point you're deprecating the runtime, and then you're just in the next end releases you're dropping the runtime and making something else the default runtime.
And for the Power 7 and up stuff, this is certainly coming very soonish as well in Fedora, because I mean, now that we actually have really nicely running still till I think down to Power 5 Fedora 20, that's a good OS, and at some point then we say, all right, you can actually run your old whatever 604 is on that, maybe even still, and be happy, right? But that's the end of the line at some point, and this is going to happen soon. So, because it's as you said, I mean, it's also for us. It's we have to basically disable.
No, secondary arches are a huge support headache. I mean, Debian dropped a lot of arches.
Yeah. Absolutely,
because they couldn't afford to maintain the 11 arches they were maintaining at 100% build. Even the package maintainers are like, why does my package get rejected if I can't have it build on, I don't know, HPPA or Power 64?
Secondary arches are much easier to deprecate older hardware than the primary arches. I'd like to have a discussion about deprecating 32-bit x86. But that's going to be a hard one.
No, people don't even want to. People want more kernel support for doing weirder things with 32-bit x86.
And I mean, as another example here, we've actually had a lengthy chat with IBM on the System Z side about dropping 32-bit, 31-bit, whatever you call it. It's 31, 32-bit. For System Z in Fedora as well. And in the length, obviously, for RHEL, because I mean, that's, for us, a lot of the whole points here that we're doing is obviously that we prepare stuff also for RHEL. I mean, Fedora is our primary driver for the RHEL stuff that we're doing, innovative stuff, new stuff, but also the architectures. That's why we're investing so much there too. And so we've been asking them, would this be an issue? And they said on the System Z side, we can't do this because all the software platform groups are still relying on 32-bit System Z to be available to run.
I would say my biggest annoyance having to work with RHEL and Fedora has mostly been on the Power side, that Fedora for Power had way more runtime supported than RHEL for Power did. And so that meant that Fedora for Power has this just like weird amount of added complexity to support that now is getting is much better without Power 5 and Power 6.
And without the 32-bit power. And that's, I mean, we had the discussion with Jeff and his teams about dropping 32-bit PPC, and they were, be our guest. So, and that's the discussion we not only have with the community, but also with IBM and with partners, because this is something that you need to do consciously, where you need to really think ahead and plan ahead, not just from your own Fedora-only community perspective, but also long-term, what's going to happen 3-5 years down the road, and what's everybody planning, right? I mean, you see that at SLAS right now, SLAS 12 coming out with PPC 64LE only. That's a pretty significant indicator. So, and maybe that's the route we're going to in Fedora too.
Well,
who knows?
It's a waste of Fedora resources, and there's opportunity cost to having you guys on
and that's the point for the 32-bit PPC, where we said the work we had to put into PPC to keep 32-bit PPC running was actually even drastically higher than the new efforts even that we had to put into the PTC64 and LE stuff. Because there were so many weird things breaking all over the place that it was just killing us, really. And that's why we said, you know, we don't have 100 people working on this, and we just can't magically conjure them up.
We probably kept it 2 years longer than we should have,
yeah,
because of Yahoo.
Yeah, and now that we managed to get Yahoo out of the way with some of the work from Karsten and others as well, and Gustavo actually, and I think, who was it?
Paulo?
Paulo, yeah, exactly. We got that out of the way too.
So Phil, in the context of like Fedora.next, for the secondary arches, are you guys working with server and workstation and cloud? And are we going to see like cloud images for power?
We could do, we have talked about doing cloud images for power probably down the road as things like OpenStack and cloud providers start offering power. Definitely server.
Yeah,
definitely server.
There's been talk whether it's worth doing workstation or not. I mean, the workstation deliverables, they only want a live CD, though I'm forcing them to have an installation tree because they have to.
And it's the same conversation we're having with cloud images as well. So.
Because the question
so the
is,
difference with ARM is that there are a lot more hardware vendors, but I know the open power effort is starting to get a little more pickup. What are you guys seeing for open power? We're going to see more people, more fabs with power chips coming out?
Oh yeah, oh yeah, and more people producing boards with power chips. Now the thing we're doing differently than ARM is that the ABI and the core is much more closely maintained, so you're not going to end up with all of these, oh, somebody's got their special chip with their 3 instructions in it, and the next one has their 3 instructions, and so...
Ultimately, ARM v8 has done a lot to alleviate the deviation from core, so...
So there will be, there'll be tighter control of that, but...
But it doesn't stop it though, right? You have an architectural license from ARM, and you can do whatever the hell you want after, and Qualcomm does.
Right.
Yeah. Yes, and the likes of Apple do, but we don't care about those products.
Yeah, that's right. That's right. Those are commercial products shipping customized for special.
Yeah, and I mean Marvel has a.
But that stuff is not server. So what I really like about Fedora Next is when you clarify the role for that component or product, you immediately go, oh, it's a server role. I guess we don't really care about installing on Qualcomm hardware or Apple's ARM hardware.
Right. Yeah. And that's also one of the discussions we have now for Fedora 21 on the power and the System Z side. Which of the products are we actually going to support in Fedora? Because do we need a workstation on System Z? Seriously? I don't think I have a portable or a workstation with a System Z.
Well, you have.
I want to run Note on my 390.
Wait. Server still ships with Note.
I know Phil Brock might want to run his workstation on it.
Well, there are a few insane people in the world. I know that, but
and they can do that still.
But I mean, he's my guest to support that product. It's the same with the community again.
So Jeff, as you look at open power, do you think that IBM is going to be the provider of firmware for that, or do you?
We just open sourced the firmware for the chip.
Cool.
Wow. Nice.
Yeah.
Wow.
If you missed that post on Google+, you can go take a look at that.
I was busy writing those slides.
We did that right around the 4th of July. So we've open sourced the firmware for the platform, so you can literally, vendors can now pull that firmware, make their customizations for their platforms that they come out. By the way, that firmware has a Linux kernel embedded in it for boot reasons, small one. So and that's essentially the firmware that's underneath KVM. So
what's the license?
Apache v2. Did that intentionally so that people could create their one-offs and not have to give it back. So
fork it and put all sorts of ugly stuff in there.
Fork it and support themselves.
Yeah.
Right? The nice thing about forking it is once you have your own version, if the main one moves forward, you're on your own.
And if it breaks, you get to keep both pieces.
Exactly. All 9.
All right. The good, the fun, and the first. So just a little bit of stuff about it. why we actually do this and why it's really actually fun. Because we actually think working on those architectures is fun. I mean, come on guys, nod your heads. No, I'm just kidding. No, it's really good. I mean, because that's why we like it. It's something that's not so mainstream. It has really interesting challenges with it that we hit oftentimes. Odd hardware, and I mean, it's, for some engineers at least, it's a dream come true to work on stuff like that that's just brand new or completely different, where you just have to fiddle around with until it just works. And then it's just awesome. It works. Wow. Yay!
It's kind of cool to like dig in and solve the problems on how does this work from the ground down.
Yep.
And it helps you understand how the distro works and how all the bits fit together, and it's kind of cool.
I mean, just with the LE stuff, for example, we recently had to do an REF64 as well, too, obviously. The bootstrapping is a very, very interesting and cool challenge if you try that. And out of that is actually right now coming some of the work that we're doing in the base working group for Fedora Next, where we noticed that there is just insanity happening around build requirements and for packages where the kernel needs GNOME to build. What? Really?
Well, and half the stack needs mono, and it's like, seriously?
And so we actually now have one guy in Stuttgart, where I'm from, and he's working on a tool that actually tries to detect which build requires we actually need, and that are in packages. So he's trying basically doing reproducible builds and then dropping build requires in a proper fashion to see if things are just the same after the build. If they're identical, you probably don't need that build requirement. You might need it, but it's a potential candidate to be removed. So we can then open bugs and clean up all that mess.
I assume one of our targets for Fedora Next is to be able to do bootstraps for the distro.
It's
right?
one of the hopes I have to get to.
Okay.
So, I mean,
I don't think it's a hope. I think it's an important part of this because, at least from the, so I'll say from the core tools perspective, we want the bootstrap in order to do ABI validation from the bottom to the top. And so it really is nice for us to be able to, for example, bootstrap the base of the OS, at least stage 1, and then do Perl or Firefox build, because Firefox uses an insane amount of C++, that if you've done something wrong with C++ front end, usually Firefox is the first thing that breaks, but if you have to wait for Koji to get around to building the next version of Firefox before you figure out what went wrong,
you've got a problem.
The time between when you send your C++ changes as a build to the Koji instance and then by the time Firefox gets built, you've forgotten what you were working on.
I mean, one of the interesting figures, just to name a figure here that's really interesting is, if you take the kernel, RPM, Yum, and what else was it?
Yeah, I bet it blows up to every package you need.
If you only use those 4 packages and only use requirements, you end up with about 130 packages-ish right now. Yes, the requirements. If you want to build this, GCC was with it too, so 130 packages, which is reasonable. Let's put it that way. It's not low, but it's reasonable.
Possible. Yeah.
If you want to build this and say, let's pull in all the build requirements too, you end up with 1,800 packages.
That's crazy.
And that's the thing that I want to fix in Fedora Next.
Yeah, I think %bootstrap macro into all of the RPM spec files. I think the tools team is really happy to put this in and have it just disable docs, disable as much as they can. And then
random language bindings such as Go and mono and stuff like that.
You just want C and C++, and then the only guarantee you have is you're going to rebuild afterwards to get in the final package.
In Debian, when they are now bootstrapping on V8, they finally added variable build dependencies. So you can say, I am bootstrapping. This build dependency is not needed.
Some
all packages, with all resulting packages are marked, but they are usable.
Some packages
I'm quite happy to work with you on that.
Everyone should.
We know, I think someone just has to write up what has to happen, and then everyone will just follow suit and start with the tools.
Yeah.
And one of the big pieces, for example, where we see actually all the problems happening, or a lot of the problems happening with like the gazillion package needed, is docs generation for most packages.
But you'll just bootstrap infers minimal
yeah.
build depth, so you'll just remove docs.
Yeah, you either remove docs. Another idea that we had that we're investigating right now too with the guy we have is pre-generate docs.
No.
Well, some packages can do that.
No.
They can.
It's not going to happen at the tools team.
Not in the tools team. No, I'm not talking about GCC.
I'll just tell you from our perspective.
I know.
So I talked to Phil about this, and we talked amongst ourselves as a team what it would take to do that. And pre-generating docs unfortunately pushes the work down to the maintainer to effectively do the builds outside of the build system proper. And the amount of work that requires for auto-generated builds and auto-generated documentation is really, really high. So even if you do consider it for other higher level packages, I can give you some use cases that we even have that mean it's difficult, very difficult to maintain, primarily because it's hard to answer the question, what has changed and will my docs change?
Do I need to regenerate my docs?
Very hard to answer that question.
Absolutely.
Is it reasonable to, instead of pre-generating, to separate them and you split them off so that they build separately?
Yeah, that's what
just disable them for Bootstrap.
Yeah.
So Bootstrap implies no docs. And then you get 80% of the benefit, 90% of the benefit.
And we just, I mean, we're investigating. If we see that this is not something that the community wants and thinks is we're insane, perfect.
So
fine.
It's like, I think it's no docs and no esoteric language bindings. Like, I mean, you can't really bootstrap Fedora without, say, Python support.
No.
So it's
So how is this supposed to work on an RPM level?
You do basically define if you can set a global variable bootstrap equals 1. And in the RPM you go, if bootstrap, do this.
It becomes Fedora policy that there's a bootstrap flag that if it's set to 1, your package should be doing a minimal build. Your build depths can depend on a macro flag. It can't depend on anything else.
Well, inside the Reddit or RPM config, you can set them macro bootstrap to 1 and.
What about doing something else? We just entered weak dependencies for the binary RPMs. I don't see a reason not to do that for build requirements.
Weak build requirements?
Well, at the moment, while that has just landed, the support for that has just landed in RPM, the FPC has said no, not at all at the moment, and there's still no policy around that.
Yeah.
So, I mean, it may work, but I mean, ultimately, you end up with the same result at the outcome.
Yeah.
So,
but it might be easier from a packaging perspective.
Yeah. So, I mean, it's definitely worth investigating as a means of doing it.
Yeah.
Maybe we can
So, where can you get in contact with us? Again, apologies for missing AR64. Next time I'll send out the slides earlier, sorry. We're on all the Freenode stuff and RSC, hanging out there. We have several wiki pages, Fedora mailing lists and everything. And you can basically always grab us there. I mean, there are always people on there from different places all around the world, actually. So.
All right. Is that the last slide?
That one is the summary. So that's what I want you to take with home.
I have another question. Is there any reason why Vert Manager can't run a system S390X or a system PPC64 QEMU KVM emulator to do like a full system, so that you could run easily within Fedora a power box or something?
You can.
Okay.
We have all of that there. It's not tightly coupled into Vert Manager and then Vert.
Yeah.
But
I know that it's there. I mean, you've got the S390 system, but what I really want is just like the way I manage all my boxes now is Vert Manager.
Right.
And I want just to be able to spin up an S390.
You should work.
Yeah. So the thing is, so like Cole Robinson added support for ARM-based.
I was talking to Cole last night. Yeah.
And so Cole is the person that can help you make that happen, and he's really open to discussion about that.
Cole mumbled last night and said something about possible firmware issues.
But with IBM opening up the firmware.
Yeah, so with IBM opening the firmware, we could potentially build the firmware to enable that pre-boot emulation.
So the reason I asked that is because it's really nice to be able to get a bug report from a secondary arch, be able to emulate the secondary arch, and then look at that, what was the actual bug. If you have to run it on real hardware to reproduce the bug, you know, that's just another level you're going to have to take, but mostly you can probably reproduce it on in a simulator.
I think we're already building that emulator for you.
Yeah.
You could come pick that up from us. We have x86 emulators. Actually, no, we're not yet delivering the QEMU.
There's a little more integration work that's required to kind of make it easy enough for me, because I don't want to care about a number of these secondary things I have to worry about, like do I have to pass the kernel on the command line? What VirtIO options do I have to enable for this architecture to run? Like, I don't know any of those things. I don't remember any of that stuff.
Yeah.
And what I want is exactly. So while you say it's supported, what I want is a recipe to be able to get one of those systems up and running.
It worked with hacks for ARM, for example.
Yeah.
We
But for ARM, absolutely, because for ARM, I was involved in the ARM part of that ARM port, and so we had this. We had QEMU, and we had the kernel image, and we had the Fedora 2021 disk images that you could then run and boot your box, and that's how we did verification of builds for the core tools. But we wanted to, we want that plumbed all the way
across all the secondary options.
Otherwise, what you really want is you want a build farm with physical boxes and access to
we have those in Tucson. What's the?
I think that's what Cross is really saying. A few Power8 boxes showed up, you know.
Those are how do those Power8 boxes get exposed easily to FAS account users?
At the moment they don't, because there's security implications.
Yes, absolutely. But again, to give examples, Debian has Debian developer boxes.
Yeah.
That once you're in DD, you get access to devel boxes and can do stuff on physical hardware.
You can go to university. We have 2 universities that have farms like that for development. So do it.
Good discussion.
If I understand that, it's process integration with things that Fedora users develop.